will be learning the concepts of pair of linear equations in two variables. So let's see what equation is. In the chapter polynomial, we have seen what an algebraic expression is. So when one of the algebraic expression is equivalent to some other algebraic expression, the representation which we are getting is an equation. Like if we are going to take an example, suppose I am saying that one of the expression, that is 2x plus 3, it is equivalent to a constant algebraic expression, that is your 7. So such type of representations is known as equation. Here there are two parts, one towards the left of the equivalent to sign and one towards the right hand of the equivalent to sign. So this towards the left is known as LHS part and towards the right it is known as RHS part. So whenever we are representing two algebraic expressions equivalent to each other, such type of representations are known as equation. Now let's see what a linear equation is. We have already learned that linear means 1. When the degree is 1, when there is an equation whose degree is 1, then such type of equations are known as linear equations. Linear equations with the degree 1 is known as equations with the degree 1 is known as your linear equation. So what is the standard form? Now let's see what is the standard form of linear equation in one variable. If we are talking about linear equation in one variable, so its standard form is ax plus b equivalent to 0. This is the standard form of linear equation in one variable. Here only one is the x is the variable, a is the coefficient of x and b is the constant term, where a and b are any real numbers and a cannot be 0. So when these type of equations we are having, we say it as the standard form of the linear equation in one variable. Now the standard form of linear equation in two variables, if we are going to take, instead of one variable, if we are going to take two variables, then the standard form of linear equation in two variable will be ax plus by plus c equivalent to 0. Here one of the variable is x, another variable is y. A is the coefficient of x, b is the coefficient of y and c is the constant term, where a, b, c are any real numbers. So this is the standard form of linear equation in two variables. Now let's see how to find the solution of a linear equation, or what is the solution of the linear equation. Whatsoever the value of the variable satisfies the equation, means the value of the variable for which your LHS part becomes equivalent to the RHS part is known as solution of the equation. Now suppose I am taking this example only. If I am saying 2x plus 3 equivalent to 7, it is for linear equation in one variable. So if I am going to solve it, 2x will be 7 minus 3, this is positive 3. When we will change the direction, it will become negative. So it is 7 minus 3, or 2x is equivalent to 4, or we can say x is equivalent to 4 by 2, that is 2. That means if we are going to keep x is equivalent to 2 in this equation, your LHS part will become equivalent to the RHS part. That means 2 is the solution of this equation. Now if we are going to take the linear equation in two variables, suppose I am saying x plus y plus 7 equivalent to 0. If this is a linear equation in two variables, then what will be the solution of this equation? Let us check it out. Now we can write it as x plus y is equivalent to minus 7 also. If we will take x is equivalent to, suppose I am taking x is equivalent to minus 2, that means if I am going to take, here I have taken x is equivalent to minus 2 plus y is equivalent to minus 7. So we can say y is equivalent to minus 7 plus 2, or it will be minus 5. That means if x is equivalent to minus 2 and y is equivalent to minus 5, this equation will satisfy. That means for this pair of solutions, for this pair of values, your LHS part will become equivalent to the RHS part. So this is one of the solution, minus 2, minus 5. Similarly, we can take other values of x and y also. For that, your LHS part will become equivalent to the RHS part. Suppose I am taking x is equivalent to minus 3. If I am taking x is equivalent to minus 3, so this equation will become minus 3 plus y plus 7 equivalent to 0, or we can say y is equivalent to minus 3 plus 7 will be your plus 4. If it will go over there, it will become minus 4. So if y is equivalent to minus 4 and x is equivalent to minus 3, then also your this equation will be satisfied. That means your LHS part will be equivalent to the RHS part. Now we can see that there are multiple or infinite of the values of x and y for which your LHS part will become equivalent to the RHS part. That means there are infinite solutions of these type of equations. For the linear equation in one variable, there is only one solution of the variable, one value of the variable for which your LHS part will become equivalent to the RHS part. But for linear equation in two variable, there are infinite values of the variables for which your LHS will become equivalent to the RHS. That means there are infinite solutions of these type of equations. Now let's see what is pair of linear equations in two variables. Whenever we are saying pair, that means we are talking about two. So if there are two linear equations in the two variables and with the same variables, means both the two equations are with the same variable, then we are saying it to be pair of linear equations in two variables. Suppose I am saying that one of the equation is 2x plus 3y is equivalent to 7. Another equation is 3x plus 5y is equivalent to 12. So there are two equations and both of them are linear equations only, and they are in the two variables, and in both the equations the variable is same. So such type of linear equations in two variables are said to be pair of linear equations in two variables. Now what is the standard form of linear equations, pair of linear equations in two variables? So standard form of this is a1x plus b1y plus c1 is equivalent to 0 and a2x plus b2y plus c2 equivalent to 0. Here a1 is the coefficient of x, b1 is the coefficient of y, and c1 is the constant term. a2 is the coefficient of another linear equation, b2 is the coefficient of y, and c2 is your constant term. So here we have seen that a1, a2, c1, C2, B1, B2. All these are real numbers. All these are your real numbers, and along with that A1 square plus B1 square is not equivalent to 0, and A2 square plus B2 square is not equivalent to 0. By this condition we are taking to ensure that these are making linear equation in two variables. And this is the condition we are taking because we are ensuring that the variable either a1 or b1, either of the two is having a non-zero value, because this is a condition which will be satisfied only if a1 is 0 and b1 is 0. And if a1 and b1 both are 0, in this condition your c1 will be 0, this will be the equation, and that won't be the equation in two variables. That's the reason to ensure that this is forming a linear equation in two variables. We are taking the condition that a1 square plus b1 square should not be equivalent to 0, and a2 square plus b2 square should not be equivalent to 0. Now let's see what is solution of pair of linear equations in two variables. Just now we have seen that the value of the variable for which your LHS part becomes equivalent to the RHS part is known as solution of the linear equation. Now for the pair of linear equations, when we will be taking two equations in the same variable, same two variables, suppose I am saying x plus y is equivalent to 7 and x plus 2y is equivalent to 11. These two are pair of linear equations in two variables because in both the equations your variables are same, that is x and y are the two variables for both the two equations. So the value of x and y for which your both the equation will be true. That means if the value of x and the y for which your for this equation even LHS part becomes equivalent to the RHS part, and for this equation even your LHS part becomes equivalent to the RHS part, will be the solution of this pair of linear equations. So if I am going to take, suppose x is equivalent to 3 and y is equivalent to 4 over here. So for this equation, your LHS, that is the left hand side part, will become, x will be keeping as 3 plus y we are taking as 4. So 3 plus 4 will become 7 and it is equivalent to your RHS. That means if we are going to keep x is equivalent to 3 in this equation and y is equivalent to 4 in this equation, your LHS part becomes equivalent to the RHS part. That means it is the solution for this equation. Now we are checking for this equation. Here even we are taking the LHS part only and keeping x is equivalent to 3 and y is equivalent to 4. So it will become 4 multiplied by 2 will become 8 and 3 plus 8 will be 11. That is your RHS part. That means for the same values of x and y, that is 3 and 4, your this equations also LHS part becomes equivalent to the RHS part. That means this pair of solution, this pair of values is true for this equation also and for this equation also. So these type of values of the variable which is true for both the two equations is known as solution of pair of linear equations in two variables. There are various methods of finding the values of this, means solution of these pair of linear equations in two variables, which we'll be discussing. So there are, one of the method is your geometrical method, or we can say it as graphical method. Another method is your algebraic method. In the algebraic methods, there are even sub parts of it. In the algebraic method, substitution method is there, elimination method is there, cross multiplication method is there. All these are the method by which we can find the solution of these pair of linear equations in two variables. So in this chapter we'll be discussing all this. Mainly we'll be discussing the graphical method of finding solutions. In the algebraic we'll be discussing substitution method and the elimination method. Cross multiplication method is beyond our syllabus, so we won't be discussing this. Rest all the three methods we'll be discussing for finding solutions of these equations. Now let's see about system of pair of linear equations in two variables. There are two systems of pair of linear equation. One is consistent and another is inconsistent. A system of pair of linear equation is said to be consistent when it is having a solution. Means if there is any value of the variable for which your pair of linear equations is satisfying, that means it is true, then such type of pair of linear equation is your consistent. There could be one solution also, and there could be infinitely many solutions also for the pair of linear equations. So if the system of pair of linear equation will be consistent if either it is having a solution or it is having infinitely many solutions. And the system of pair of linear equation will be inconsistent if there is no value for the pair of linear equations for which both the equations satisfies. That means if there is no solution for the pair of linear equations, in that case it will be known as inconsistent, and if there is either a one solution or infinitely many solutions, then such type of pair of linear equations will be having consistent system. If there is only one unique solution of the equations, if there is only one unique solution, then such type of pair of linear equation is having consistent system. And if there are infinitely many solutions for the pair of linear equations, if there are infinitely many solutions, then such type of linear equations are also known as dependent also, and they are consistent also, because they are having solution. That means they will be consistent. But if there are infinitely many solutions, then such type of linear equations are known as dependent equations also. And if there is no solution for the pair of linear equations, if there is no solution, then such type of pair of linear equations are known as inconsistent pair of linear equations. So either there will be possibility that there is one solution for the pair of linear equation, or there could be infinitely many solutions also, or it is even the possibility that there is no solution for the pair of linear equations in two variables. If there is only one unique solution, then it will be consistent. If there are infinitely many solutions, then it is also known as dependent or consistent, and if there is no solution, it will be inconsistent. Now let's see how to find solutions of pair of linear equations using graphical method. In the previous classes, we have seen that for the linear pair of equations, if we are going to draw the graph, then it is always a straight line. In the chapter polynomial also, we have learned that for a linear equation, the graph is always a straight line. Now, we have even seen that if we are taking two straight lines, if we are going to take two straight lines in any plane, then there are three possibilities are there. Either the lines will be parallel and there is not even a single point where both of them will intersect each other, because distance between both of them will remain same throughout, then there won't be any point for which this equation and this equation, that means both the equations will satisfy, there won't be any such solution. Another possibility could be that the two lines will intersect each other. If this is the condition, that there will be this point will be the solution of the equation, because this is the point which will satisfy this equation also and it will satisfy this equation also. So for this type of intersecting type of condition, there will be only a unique solution which will satisfy both the two equations. There could be another possibility that both the two lines overlap each other or coincide each other. In this condition, there are infinitely many points which will satisfy both the two equations, because every point on this equation will be the solution of these two equations. So there are three possibilities are there. Whenever we are graphically representing any two lines, then either they will be parallel, or they will be intersecting, or they will be coinciding. Now, just now we have seen if there is a unique solution, it is known as consistent system. If there is infinitely many solutions, then it is either dependent or consistent, and if there is no solution, then these type of system is your inconsistent system. So these three are the possibilities when we are representing any equations, any pair of linear equations in two variables graphically. Now let's see how to find it out. Suppose we have taken an example. We have taken two equations. One is your x minus y equivalent to 3. Another is 2x minus 2y is equivalent to 8. These two are pair of linear equation in two variables, because for both the two equations, the variables is same. Now for this, suppose we are taking y is equivalent to 1. If we are going to take y is equivalent to 1, so the equation will become x minus 1 is equivalent to 3, or we can say x will be 4. So one of the solution for this equation will be 4, 1. Value of x is 4 and value of y is 1. If we are going to keep these values in the equation, this will be the solution of the equation. This will satisfy the equation. Another point could be if I am going to take y is equivalent to 0. In that case, x minus 0 will be 3, or we can say value of x will be 3. So another solution for this equation will be 3, 0. 3, 0 will be another solution for this equation. Similarly, we can find if y is equivalent to, suppose I am taking minus 1, so it will become x minus 1 is equivalent to 3, or we can say minus will become plus 1, so it will be 3. This plus 1 will change the direction, will become minus 1, or x will be 2. So another solution will be 2, minus 1. So what we will be doing for every equation, we will be taking three solutions. Then we will be converting into tabular form like this. For the first equation, this is the value of x, this will be the value of y. First pair is if the value of x is 4, value of y is 1. For the second, if the value of x is 3, value of y will be 0. For the third solution, if the value of x is 2, value of y is minus 1. If we will plot these coordinates on the graph paper, we will be getting a straight line. Like this, we will be taking x-axis here and y-axis here. This is your x, this is x dash, this is y dash, this is origin. Here it will be one positive direction. For x, it is negative x, minus 2, minus 3 like that. Here it will be positive y, 1, 2, 3. Here it is negative y, that is minus 1, minus 2, minus 3 like this. Now we will plot this. For the first, x coordinate is 4 and y coordinate is 1. So x coordinate 4 here, 1 is your y coordinate. So if you will move upward till 1, this will be the first point, that is your 4, 1. Now the second is, if the value of x is 3, y is 0. If x is 3, y is 0, so this will be the point. Third is, if x is 2, y is minus 1. If x is 2, y is minus 1, so here it will be the point. So if we will join them, it will be a straight line. This point, it will be your 3, 0. It is your 2, minus 1. So if we will plot this line, it will be a straight line. Similarly, for the second equation, we will be finding 3 coordinates which will satisfy this equation. Suppose I am taking y is equivalent to minus 1. If I will take y is equivalent to minus 1, 2x minus 2 multiplied by minus 1 is equivalent to 8. So it will become 2x minus minus will become plus 2. It is equivalent to 8. Or we can say 2x is equivalent to 8 minus 2. That is your 6. And x will be 3. So the first coordinate is 3, minus 1. When the value of y is minus 1, value of x is 3. Similarly, we can find the second coordinate. If I am going to take y is equivalent to minus 2. If y will be minus 2, it will be, equation will become 2x minus 2 multiplied by minus 2 is equivalent to 8. So it will be 2x minus minus when multiplied together, it will become plus 4 is equivalent to 8. Or you can say 2x is equivalent to 8 minus 4, that is 4, or x is equivalent to 2. So the coordinate that will satisfy this equation will be 2, minus 2. Similarly, we can find the third coordinate also, and we can represent this in this tabular form. Like this, if I will be taking like this, another table I will be making, it is for x, it is for y. If the coordinate of x is 3, coordinate of y will be minus 1. If it is 2, it will be minus 2. Similarly, we can find one more. If I am taking over here minus 3, a value of y will be minus 3, it will become plus 6. And if it will go over there, it will become minus 6. That will be 2, and 2x is equivalent to 2. So y will be 1. X will be 1. If y is minus 3, value of x will be 1. We can plot this line even over here in the graph. So if x is 3, y is minus 1. If x is 3, y is minus 1. So here it will be, if x is 2, y is minus 2. If x is 2, y is minus 2. It will come somewhere here. If x is 1, y is minus 3. If x is 1, y is minus 3. Although it is not accurate because we have not taken accurate dimension, we have not used ruler. If you will be using, so again it will be a straight line like this. If you are going to join this, it will be a straight line which will be parallel to the previous line. So any of these three conditions could be there. Either the two lines will be parallel, or they will be intersecting, or they will be coincident. So if any of these three conditions occurs, if it will be an intersecting line, then the point at which they are intersecting, when we will plot it graphically, the point at which they will intersect will give you the solution of these two equations. That point will be the point for which your both the two equations will be true. That will be the solution of these two pair of linear equations. And if they are parallel, obviously there won't be any solution. It will be inconsistent. If they will be coinciding each other, then there will be infinitely many solutions. So they will be dependent and consistent. This is how we can find the solution for a pair of linear equation in two variables by graphical method. Now let's see how to find solution of the pair of linear equations using substitution method. As the name suggests, substitution means we have to keep the value of a variable from one equation, and we have to keep this value of the variable from one equation to the another equation. Why we will be doing so? Because we have to find a solution. Solution means the values of the variable for which will satisfy both of them. That means if we are going to keep the value of x, what same value if we will keep it over here, the value of y which we are keeping over here, and if we will keep the same value of y here also in this equation, in both the cases your LHS part will become equivalent to the RHS part. That means that will satisfy both the equation, that will be the solution for both the equation. Means value of x and y should be same for both the two equations. Now let's understand by an example. Suppose one of the equation is 2x minus 3y is equivalent to 3 and the another equation is 3x plus 5y is equivalent to 14. So what we will be doing, from any of these two equations we will be finding either the value of x or the value of y. From here, if we will be taking the value of x from here, so this equation could be written as 2x is equivalent to 3 plus 3y. This minus 3y will change the direction, will go to RHS side and it will become positive. So 2x will be equivalent to 3 plus 3y. Now if 2x is equivalent to this, so what will be the value of x? Value of x will be 3 plus 3y divided by 2. This will be the value of the x. We are assuming that this equation is equation number 1 and this equation is equation number 2. So from equation number 1, we have found the value of x in terms of y. So value of x is 3 plus 3y over 2. Suppose this is equation number 3. Now from equation number 3, we will keep the value of x in equation number 2. Because from here, the value of x is this and the same value should be for the equation number 2 also. Then only it will be the solution for both the two equations. So we are keeping the value of x from here in this equation number 2. So this will become 3 multiplied by x is 3 plus 3y divided by 2 plus 5y is equivalent to 14. Now this whole equation is in one variable only and we can easily solve this equation because we know how to solve the equation in one variable. Now what we will be doing is, first of all we will be taking an LCM in the LHS part. 3 multiplied by 3 will become 9. 3 multiplied by 3y will become 9y. If 2 I have taken the LCM, so it will be multiplied by 2 because over here denominator is 1 only. For making the denominator 2, we need to multiply and divide it by 2. So this will become 10y and it is equivalent to 14, or we can say 14 by 1 also. Now further we will be solving 9 plus 10y plus 9y will be 19y and 2 will be multiplied over here because it is in division and it is a denominator of whole the numerator. So we can multiply this 2 by 14. 14 2s are 28. So it will become 19y is equivalent to 28 minus 9. That will be value of 19y is 19, or we can say value of y is 19 divided by 19, that is 1. So value of y is 1. Suppose this is your equation number 4. From here we got the value of y. Now if we will keep this value of y in this equation, that is equation number 3, we will be getting the value of x also, because we want the value of x and y only for which both the equation will be true, which will be the solution for both the two equations. So from here value of x will be 3 plus 3 multiplied by y we are keeping as 1 divided by 2. So 3 plus 3 divided by 2, that is 6 by 2, or we can say 3. So value of x is 3. That means if we are going to keep x is equivalent to 3 and y is equivalent to 1 in both the two equations, that will be satisfied. That means it is the solution for these two pair of linear equation. Here we are getting the one unique solution, right? That means it is your consistent type of equations. Now there could be a condition when your variable part will be diminished, it won't be there in the equation, and if something like this is coming, say 12 equivalent to 12, if it is this type of statement is coming which is true for all condition, that simply means it is your dependent type of equations, dependent or consistent type of equations. And if the condition is coming like 7 is equivalent to 13, so it is not true for any condition. That means these are the equations whose type will be inconsistent. As just now we have discussed that there will be three possibilities could be there. One, there will be unique solution. This is the condition when there is a unique solution. That means if we will draw the graph of these two equations, these two lines will intersect each other at a unique point. There could even be the condition when there are infinitely many solutions. There could be the condition when there is no solution in the case of parallel lines. So how we will come to know? This is a simple condition when we are getting the values of unique values of x and y for which both the two equations satisfy, which is a solution for both the two equations. But if further when we are solving, we are getting a equation in which variable is not there and the statement which is true for all condition. In that case, this will be these type of equations for which we are getting this statement will be dependent or consistent type of equations. That means these two equations will coincide each other. And there could be the possibility when we are coming to a statement like this which is not true for any condition. In this type of condition the pair of equations will be your inconsistent type of equations. So this is how we can solve the pair of linear equation. We can find the solution of the pair of linear equations by substitution method. Now let's see how to find solutions of pair of linear equations in two variables using elimination method. As the name suggests, elimination, that means we have to eliminate any one variable from both the two equations and then we'll be getting equation in one variable and we can solve it further for finding the values of both the two variables. How we'll be doing that? Just see it. Over here we can see that the coefficient of x is 1 and coefficient of y is 3 in the first equation. In the second equation we will see the coefficient of x is -2 and coefficient of y is 5. For any one variable, either for x or for y, we have to make the coefficients equal. Now what we'll be doing, we can see over here, if we will multiply this by 2, it will become equivalent to your 2x from which is in your second equation. So suppose we are assuming this equation to be 1 and this equation to be equation number 2. If we will multiply equation number 1 by 2, we'll be getting the whole equation will be multiplying by 2. So this will become 2x plus 2 multiplied by 3 will be 6y is equivalent to 2 multiplied by 10 will be 20. This will be the third equation. What we have done, we have made the coefficient, numerical coefficient of x equal in both the two equations. Now here the coefficient of x is +2 and here the coefficient of x is -2. If they are unlike signs, then we will be adding these two. If we will add this equation and this equation, that means equation number 2 and equation number 3, if we will add these two equations, your coefficient of x will be in opposite direction. That's the reason they are going to cancel and we will be getting an equation in one variable only. Now let's see, we are writing it over here only, -2x, equation number 2, plus 5y. It is equivalent to 6. This is your equation number 2 and we are adding these two equations. Now when we will add these two equations, they are having opposite signs. So they are going to cancel. 6y plus 5y will become 11y and it will be 26. So this is an equation in one variable only. Now we can find the value of y from here. So value of y will be 26 by 11. This is the value of y for which your both the equations will be satisfied. Now we have to find the value of x for this y. If the value of y is this, what will be the value of x? We can keep the value of y in any of these two equations. Suppose in equation number 1 we are keeping this and this is your equation number 4. From equation number 1 and equation number 4 we can say that x plus 3 multiplied by 26 over 11, it is equivalent to 10. From here we have kept the value of y in the equation number 1. Now this will become x plus 3 multiplied by 26, 18, 3 to 6 and 1, 78 over 11. It is equivalent to 10. So we will be taking LCM over here. It will become 11. 11x plus 78. It is equivalent to 10. Now we can cross multiply it. So this will become 11x plus 78 is equivalent to 11 into 10 will be 110. So 11x will be 110 minus 78. So this will be 32. That is the value of 11x, and the value of x will be 32 divided by 11. So for the value x is equivalent to 32 by 11 and y is equivalent to 26 by 11, your both the two equations will be satisfied. Your both the equations LHS part will become equivalent to RHS. That means this is the solution for these two equations. So what we have done is, using elimination method, we have eliminated any one coefficient. For that, we have to make any one variable, the coefficient of any one variable, numerically equal. If their signs are coming unequal, then we will be, means of opposite signs. In that case, we will be adding these two equations, and if both of them are having same signs, then we will be subtracting these two equations. By this, we can eliminate one of the variable and we will be getting equation in another variable, that is single variable only. We can find the value of that variable from that, and keeping this value in any of these two equations, we will be getting value of the other variable. So this is the way by which we can solve the pair of linear equations using elimination method. There are other possibilities also. Like if we will be solving, it is one of the possibility when we are getting a unique solution for this, as we had discussed earlier also. This is the condition when we are getting a unique solution, but there could be the statements. When we will be solving it, we can get a statement where there is no variable part, and we are getting a statement which is true for all the condition. That simply means we can interpret from that it is the pair of equations are your coincident equations. That means it will be having multiple solutions or infinitely many solutions it will be having. Or if we are getting the statement which is not true for any of the condition, in that case we can conclude that this equation, this pair of equations is having no solution. They will be parallel lines. So by this method we can find either the solution will be unique, a unique solution will be getting, or infinitely many solutions will be there, or there will be no solution. This by way we can find it out. Till now we have seen various methods of finding solution of pair of linear equations in two variables, that is graphical method and algebraic methods. And in algebraic method, substitution method and elimination method. Now, by simply comparing the coefficients of x and y, and by simply comparing the constant terms, we can come to know that what will be the nature of these linear equations. What will be the nature of the lines that will be formed while we will be plotting these linear equations. Now we know that the standard form of the linear equations in two variable is a1x plus b1y plus c1 is equivalent to 0, and a2x plus b2y plus c2 is equivalent to 0. If we will compare these two standard forms of the equations with these equations, suppose we have taken these as an equation, so we can see that value of a1 is 2, value of b1 is minus 4, and value of c1, if we will write 3 over here, so it will become minus 3. So value of c1 is minus 3. Similarly, value of a2 is 2, value of b2 is minus 1, and value of c2 is minus 5. If we will take the ratio of a1 to a2, b1 to b2 and c1 over c2, we will come to know that a1 over a2 is 1 by 1, value of b1 over b2 is 4 by 1, and value of c1 over c2 is 3 by 5. So we can see over here that a1 over a2 is not equivalent to b1 over b2. If we will plot these type of equations graphically, so we will see that these type of lines will be intersecting lines. That means they will be having a unique solution. They will be intersecting at a point. And if we will solve these equations using algebraic method, then we will be getting a unique solution for these equations. And the system type will be consistent because we are having the solution of these equations. So system type will be consistent. Now the second condition will be when we will compare these coefficients. So value of a1 over a2 will be 2 upon 4. Value of b1 over b2 will be minus 4 over minus 8, that is again 1 upon 2, and value of c1 over c2 will be minus 3 over minus 6, that is 1 upon 2. So we can see that the value of a1 over a2 is equivalent to b1 over b2 is equivalent to c1 over c2. When these type of relation comes, then if we will plot these type of lines on the graph, we will see that these lines will be coinciding each other. Or if we will be solving these type of equations algebraically, we will find that there will be infinitely many solutions for these type of equations. That means the system type of these type of equation is your consistent because it is having solution, and because it is having infinitely many solutions, so it will be dependent on also. Now the third type of equations will be, if we will be compare these type of equations, a1 over a2 is over here is 1 by 1, b1 over b2 is minus 1 over minus 1, that is 1 by 1, and c1 over c2 is 6 by 3, that is your 2 by 1. So we can compare these and we can say that a1 over a2 is equivalent to b1 over b2, but it is not equivalent to c1 over c2. When these type of equation comes, and if we will plot it graphically, we will see that the lines formed will be parallel to each other. And if we will solve it algebraically, we will see that there will not be any solution for these type of equation. Or we can say, because there is no solution, so system type of these type of equation is inconsistent. So by simply comparing the ratios of your coefficients, we can come to know that what type of equations it will be, whether they will be having solution or not, whether they will be having multiple solutions, or whether they will be having no solution. By simply seeing, we can say that it will be having unique solution, or infinitely many solution, or no solution. Again, we can see if a1 over a2 is not equivalent to b1 over b2, then these type of lines will be intersecting lines, and these type of lines will have a unique solution. They will be consistent. If a1 over a2 is equivalent to b1 over b2 is equivalent to c1 over c2, then these type of lines will be coinciding lines, and they will be having infinitely many solutions, and they will be consistent and dependent. Similarly, if a1 over a2 is equivalent to b1 over b2 and is not equivalent to c1 over c2, then these type of lines will be parallel lines. They won't be having any solution, and their system type will be inconsistent. So simply by comparing the ratio, we will come to know, we can conclude all these things. Now let's see few questions related to it. The first question is, for which values of p does the pair of equations has unique solutions? Here the pair of equations are given to us. We can see over here, from here px plus py plus 8 equivalent to 0, and here 2x plus 2y plus 2 equivalent to 0. Just now we have read that for unique solution, the condition for unique solution is that a1 over a2 should not be equivalent to b1 over b2. If this condition satisfies, then we can say that the pair of linear equations will have unique solutions. If we will compare these equations with the standard form, then we can see that the value of a1 over here is 4, value of b1 over here is p, value of a2 is 2, and value of b2 is 2. Now, if we will keep these values over here, so we can have a1 means 4 upon 2, a1 over a2 should not be equivalent to b1 is p and b2 is 2. This should not be the case. If we will cross it, it will be 2. That means 2 should not be equivalent to p upon 2. If we will cross multiply it, means value of p should not be 4. That means except the value 4, if p is having any other real number, the value of p is any other real number, then for that it will be having unique solution. For the unique solution, p should not have value 4 except for if there is any other real number value of p, then it will be having a unique solution. Now the second question, for what value of k will following pair of equations have infinitely many solutions? Now we have seen for infinitely many solutions, the condition is a1 over a2 should be equivalent to b1 over b2 should be equivalent to c1 over c2. For infinitely many solutions, this is the condition. Now compare value of a1 is k, value of b1 is 3, value of c1 is minus of k minus 3, value of a2 is 12, value of b2 is k, value of c2 is minus k. Now if we will keep all these values in this equation, it will become a1 that is k upon 12, a1 over a2 that is k upon 12 should be equivalent to b1 over b2 that is 3 upon k, should be equivalent to c1 over c2 that is minus of k minus 3 divided by minus of k. These two minus signs are going to cancel. First of all, we are taking these two conditions. From these two, if we will cross multiply, so k multiplied by k will become k square is equivalent to 12 multiplied by 3, that is 36. Value of k square should be 36, or we can say value of k should be square root of 36 or plus minus of 6. Means from this first condition, the value of k could be either plus 6 or minus 6. Now we will be taking these two conditions. From here, if we will multiply 3 by k, it will become 3k should be equivalent to k multiplied by k minus 3. So k multiplied by k minus 3. From this condition, we have interpreted this. Now if we will be solving it further, 3k is equivalent to k into k will become k square minus k multiplied by minus 3 will be minus 3 of k. Now if we will be taking this over here, so this will become, here it will become 0 and it will be k square minus 3k minus 3k, or we can say k square minus 3k will be minus 6k, it is equivalent to 0. Now k could be taken common from here, so we have taken common k taken common, remaining will be k minus 6 equivalent to 0. Now from this, if we will consider k equivalent to 0, so value of k will be 0 from here, and if we will take k minus 6 equivalent to 0, so from here value of k will be 6. Now from the first condition, it could be either plus 6 or minus 6. From the second condition, the value of k could be either 0 or 6. From both of them, we can interpret that value of k should be 6. If the value of k will be 6, then for this value, this whole pair of linear equations, both of them will have infinitely many solutions. They will be coinciding each other and they will be having infinitely many solutions. Hope these two solutions are clear to you and the concepts of the chapter is even clear to you. You must have liked the video also. Please do subscribe and like the videos for many more videos related to mathematics. Thank you.